Hi, this is Igor Rijanovic from hdhead.com, and I will talk to you about more expressions in Avid DS. All of these expressions will be available for download at the end of the tutorial, so don't worry about not being able to follow what's going on, because you'll be able to download this and play with it. Let me show you what I have on the timeline. We'll talk about creating a basic sine wave. We'll learn how to make a delay where objects are following a lead object. Also apply that to something like simulating a radar screen, and then creating a meter that also has audio. So let me show you how these effects work one by one. This consists just of a simple DV clip effect. If I open that, right mouse click on Y and go to expression editor, this is all that we really need. So sine wave, I will delete this and create it from scratch so you can see what's going on. We can go to insert, sine, and here we have to enter a value that's changing, otherwise sine function will be returning the same value. So the best thing to use is FC, which returns the value of the current frame. So it's a constantly changing value as long as the timeline is advancing. If I apply this, and let's move these windows so we can see what's happening there. You see very little is going on. If you look at the values of the Y over here, it's a sine wave is just returning values between -1 and +1. So we need to multiply that with let's say 200, and as you imagine, this number will determine the amplitude of our effect here. So if I apply this and now move the timeline, the box is moving up and down ±200 pixels. So this is amplitude and this is frequency. If we divide this by 10, for example, apply, now the frequency has slowed down, so the box is moving slower. And if we multiply this by 10 and apply, the frequency is much higher, so you can see now the box is jumping up and down like crazy. So those are the only things you need to remember. You need a changing value in here. If these numbers are larger, the frequency will be higher, and this determines the amplitude. In our second effect, there's also sine wave motion, but what's going on is the second and the third boxes on the right are following the first one on the left. And if we go to expression editor, this is achieved by using @_frame. What @_frame does, it returns a value from input 1 that happened 10 frames ago. So really what's going on here is input 1 is DVE translate Y. So input 1 is this first DVE movement up and down. So what we're telling the DS here is to look at that input and pull a value from that input from 10 frames ago and put it in as the value of DVE2 over here. So the vertical position of this one is where this box was exactly 10 frames ago, and this one is another 10 frames, so this one is -20 frames, and that's how we achieve a delay. So the trailing boxes are repeating the motion that already happened 10 frames ago. This is an interesting and important effect because to manually animate all these boxes trailing would really take a long time, and by sequencing every additional DV in the same way, you could make a really long chain of movement with very little effort. And of course the DV doesn't necessarily need to move in just one direction, it can really go anywhere. So if I take it out of frame, these boxes will follow as well. So here we go up and down, and there they go. And again, observe how they follow with a delay. So move, move, move. A similar delay effect is used here in the radar effect, and that's constructed in a very similar fashion. There are 4 lines, and they're trailing behind the leading line with some custom properties here using Property Builder. What we can do is I have a delay value and a fade value. I can fade the trailing lines, or I can show them all, And I can also change the amount of delay by using this delay property. See how the spokes are now getting more and more separated. Then we have this effect that looks like audio meters, and also has some sound, which unfortunately you can't hear well, but I will play it for you. If you look inside, we have a bar graphic that's replicated a number of times and then composited together. And in each one of these DVEs, the crop value is an expression. It's using a random generator and noise function to determine the placement of the crop. So these things are jumping up and down. Noise generator is a little different from random number generator because it generates continuous values. So if you look at the output of a noise graphically, it looks less random because it's continuous. It goes up or down. And it's more suitable for something like this, like it's supposed to simulate audio meters. The random generator ensures that all these bars are sufficiently random and differ from each other. Right underneath this on the audio track, we have a sinus function with a random number generator as well, making this chirpy, high-pitched sound that sounds like this. And then we have another effect that's using expressions, very simple expression, t times 1000. T returns the time value of the current clip, and it's a continuously ascending value, so it will make a sound that goes from a low frequency up to a high frequency. It sounds like a shortwave radio tuning. After seeing this quick tutorial, the best thing you can do is download these presets and play with them, modify the parameters and see how you can utilize them for your needs. And they will also allow you to learn more about manipulating these and creating your own presets.